Thank you very much. Thank you, Christine, and other colleagues at Bergen Energy Lab. I would like to thank particularly Professor Ignacio for inviting me to this interesting seminar. Uh, the topic today is the interplay between offshore wind farms, fisheries, and climate change. I just made a little subhead. It's a gusty wind or a cool breeze. The significance of this subtitle or maybe header is the word cool in it. It's because climate change um, creates global warming. So we need to cool it down. And that's why a cool breeze basically denotes that our process against climate change, addressing climate change, is to reduce the temperature uh, uh, against the global warming. So let's begin. This presentation is based on our joint paper. Professor Ignacio and I wrote this paper for oil, gas, and energy law. It was published in last October as an advanced article, and finally, as a part of this spatial issue on offshore activities. Professor Ignacio was a guest editor for this issue of this journal, and the paper is now out, so we can see what is there. And that's why for this presentation I slightly changed the organization of the presentation. It's because the way the paper was written might not be suitable for an oral presentation purpose. So that's why I will do it a bit differently to make it more interesting. And the outline of this presentation is I start with a background and an introduction, followed by the tripartite interactions between offshore wind farms, fisheries, and climate change. And then we'll settle one issue forever. I mean, and we will not be carrying forward with the discussion on climate change because we'll settle that here. And then we'll continue with the impact on fish and marine environment, impact of offshore wind farms on fish and marine environment, and then followed by impact of offshore wind farms on fisheries, particularly fisheries. And then we'll look for possibilities of coexistence and co-locations and how regulations can um, make way for these multi-use options. And then what tools and approaches we have at our disposal to facilitate this coexistence and co-locations. Basically, how regulation can help this process, and followed by conclusion. So, as a background, we know that there have been numerous studies conducted um, to identify the interactions between offshore wind farms and marine environments, since offshore wind farms are situated in the middle of the sea. So it will have inevitably impact on fish and other marine lives. Now, the impacts are of two kinds, short-term and long-term, and the effects can be of two kinds as well, so positive and negative. These studies are mostly done from scientific perspective by natural scientists, say fish biologists, but the number of studies done on the regulatory process, regulatory aspects governing these interactions are a few. So we try to fill this gap by looking at how regulation can manage or govern the interaction between these two. And the aim of this is to maximize the benefits of these two resources by neutralizing the negative effects that we have found so far. Now, the effects of offshore wind farms on marine environment, including fish and other marine lives, these are, as we mentioned in our paper, these are well documented. And this is a special issue on my slide, Oceanography Journal. It's volume 33, issue 4, published in December 2020. This special issue was dedicated on this particular topic, the impact of offshore wind farms on fish species. So it dealt with impacts from many dimensions. For example, impact on say coastal resources, impact on fisheries resources, and then the impact of hydrodynamics and implication on fisheries, and then the impact of electromagnetic fields that is being created due to the transmission of electricity via undersea cables on fish species. So from many dimensions, the impact on fish from a biological science perspective was done and published in this particular issue. So we will not be dealing with the impact, especially on fish biology and their behaviors, because it's already well documented, it's out there, and we know that these impacts can be both positive and negative. Moving on, uh, as we mentioned that we will be bringing in the climate change in the scenario, and when put into the context, what we find is that climate change is the biggest threat facing humanity nowadays. And climate change also impacts the marine lives, and fish and other marine animals are facing existential threats due to climate change. And one way of getting rid of this or addressing this problem is decarbonization, which is by doing emission cuts maybe. And offshore wind farms can be a great tool in doing so, because offshore wind farms create clean energy. So it helps us decarbonize and cut emissions. And at the same time, these offshore wind farms have some negative effects on marine environment. But if we compare and juxtapose, um, we find that the gravity of the consequences of offshore wind farms on marine lives are far less than those of climate change. So climate change is the bigger evil, and that's why this is quite settled now that we need more offshore wind farms, and because to fight climate change, which is the bigger evil here. So that's why with this discussion on climate change will not be carried forward in the next part of the discussion. Moving on, we have these effects of offshore wind farms on fish, but in turn, these effects will also impact human beings. How? It's because of the way ecosystem works, and we already know that microplastic pollution, for example, is a menace that is impacting fish species, but ending up on impacting humans, because it comes to humans through seafood that we eat. So this is how any impact or any effects on fish and marine environment will eventually impact human beings. And that's why the modern fisheries management strategies, they focus on this principle of or approach of ecosystem-based fisheries management, or EBFM, which means everything is interconnected, and we call it the ecosystem, although we divide it in two kinds, marine and terrestrial. But at the end, we have this. The process is unitary, and everything is interconnected. So any impact on fish and fisheries and marine environment would eventually affect us as humans as well. Now we have the sustainability concept, which means economic and social sustainability along with the environmental one. So not only focusing on the impact on marine environment of offshore wind farms, we also need to take care of the economic and social considerations in order to ensure sustainability. And scientific studies are mostly done, as I mentioned before, from biological perspective, biological and behavioral aspects of fish species, but not from social, legal or economic perspectives. And these issues are mainly covered by fisheries, mainly connected to fisheries and not fish per se. This presentation for this reason will show how offshore wind farms interact with fisheries, not particularly with fish. Fisheries are the economic and social considerations of or the industry is referred to as fisheries, and fish is the biological entity that we have. So the presentation will focus on fisheries and how regulators can mitigate the conflicts that arise in the process of establishing offshore wind farms in the middle of the ocean. Now, what is the conflict? Basically, the effects of offshore wind farms on fisheries. Offshore wind farms require large ocean spaces, and how large we will see in the next slide. But in establishing these offshore wind farms, we lose fishing grounds, and due to this loss of fishing grounds, the fisher folk or the fishers, they will lose their livelihood. And it also cause overfishing in other spaces because of closing of some spaces. In most offshore wind farms, a no-go zone, no fishing is allowed. So fishers cannot go into the site, offshore wind farm site, and fish. So they go to other places, maybe adjacent places, and those places are um, being overfished. And then for traditional fishing, the loss of these fishing grounds would create some socio-cultural conflict as well. Now, these problems are mainly spatial. So the conflict between spaces distributed to multiple uses of the sea. And as I was saying that offshore wind farms require vast ocean spaces, but how vast? So here's two interesting ideas to give. One is the new projects that are being considered in the North Sea would take up, say, additional 5,000 or 10,000, 5,000 to 10,000 square kilometers by 2030. And a new project in the UK, which is Hornsea 2, would cover, say, 460 square kilometers, which is 1.5 times of the size of Malta. So it's really big. And these areas are currently being used by fishers to catch fish, but they will soon lose these if these sites are no-go zone. And then we have conflicts between two similar uses of the sea. For example, the first one we saw the conflict between living and non-living resources. So fisheries are living resources, offshore wind farms, wind resources are non-living. So that's a conflict between living and non-living. But conflicts could also arise between two non-living resources, like extraction of hydrocarbon, oil, and gas. So these non-living resources will come into conflict when we have offshore wind farms in the similar or same seascape. And then we have conflicts between these offshore wind farms and other uses, for example, navigation, conservation projects like marine protected areas, and recreational activities like recreational sailing or, say, recreational fishing, for example. So these will conflict with each other if not managed by marine spatial planning. These overlaps would create conflict, but marine spatial planning is a tool that can basically designate spaces for all these activities so that they do not conflict. We will discuss further on this later on. And then how these spaces are basically designated. So offshore wind farms require strong wind currents, places where the wind currents are really strong, and the grounds, the seabeds are suitable for putting the large installations like the turbines and the foundations. So the seabed needs to be sufficiently strong to facilitate this infrastructure. And fishing grounds are basically organically determined by fishers where they get good amount of fish in an expedition, and that's how they determine their fishing grounds. So when this collides, I mean, we have good wind currents and good seabed condition in a seascape where also the availability of fish is suitable for fishers to go to the same place and fish. So we see a conflict there. And regulators now need to find ways to maximize benefits of these two resources. One way of doing it is co-utilization of the same seascape, same sea space. It can be done by using a couple of tools and mechanisms. We will discuss this now. So this is known as multi-use options. So there are two very common approaches. One is coexistence and co-location. Sounds similar, but they're not the same. Co-location is when we do two things at the same, exactly on the same place, same space, but coexistence means two activities running side by side in adjacent places, not in the same place. Space sharing has traditionally been seen as difficult or impossible. The scientists, they didn't have enough information to decide whether they would coexist peacefully. But now the advancement of science prove it otherwise, which means now we know that coexistence is possible. The detail on this should be coming in the next 2-3 slides. And well, although coexistence is possible, but two things need to be ensured. One is the safety of the installation, and the other is the safety of the fisher folks, of their fishing gears and their fishing vessels. So safety from both sides is of paramount importance. Now, there are some fishing activities that are less active, which we call passive fishing activities, passive fishing. And aquaculture is another thing that can be allowed in offshore wind farms very, I mean, without a lot of conflict. And then recreational fishing is also possible in offshore wind farms. Another thing is the conflict between conservation and utilization. So we have marine protected areas. They take up spaces. I mean, in marine protected areas, fishing is generally not allowed. So we have another closer by offshore wind farms. So we lose more fishing grounds. Now, to accommodate the concerns of fishers, there's an approach that say we can basically install offshore wind farms in marine protected areas, and coexistence of these two is actually possible.
Arif, I know you're following the time, but you have about 6 minutes left. So just so you know.
Okay, so I need to rush. Okay, no problem. So now the drawbacks of these multi-use or obstacles to multi-use are legal drawbacks and accidents that I already have discussed. And legal drawbacks are basically in international law, we have UNCLOS that says in Article 56 and 60 that these installations that countries put in their exclusive economic zones, they need to ensure the safety of other users, and this can be done by installing safety zones, and it can be up to 500 meters. Now, countries, they can decide this. It's their right to do so, but they can basically waive these requirements if they want. And some countries have actually done so. So in multi-use options are getting tractions nowadays, and scientific findings are in favor of multi-use. And fishing is now being treated differently from navigation. And some fishing vessels of certain size are being allowed in offshore wind farms. And these safety zones that we mentioned, it's actually 500 meters as mentioned in UNCLOS, but some countries like Denmark reduces the distance to 200 meters. Um, and then UK fishing, in the UK, some fishing, passive gear fishing is being allowed in the offshore wind farms. Now, developing offshore wind farms have 4 phases, and these phases have their own impact on fisheries. These 4 phases are pre-construction, site selection, then construction, operation, which includes management as well, and then decommissioning. Each phases have their implications, and they are being governed by the licensing conditions, and that's why licensing conditions and drafting them is really important. Moving on, we have regulatory tools and approaches. Now, one tool that I already have mentioned is marine spatial planning. It's very crucial document, and this is the main document that manages multiple uses: fishing, shipping, tourism, offshore energy production, and while preserving marine environment. And then this is mainly done by laws. So we have Offshore Wind Energy Act in Greece, Offshore Energy Act in Norway, and so on. Then we also have the licensing requirements and conditions in the license agreement, which are crucial tools because that governs the activities. And then the environment impact assessment, EIA, is another crucial document or crucial activity that is there to regulate the offshore wind activities and their implications on fish and marine environment. Then life cycle approach is life cycle approach is an important thing that regulators need to take into account. Instead of taking particular phases of development of offshore wind farms, the life cycle approach is beneficial because it takes care of the entire lifespan of offshore wind farm, from planning to construction to decommissioning. It also takes care of the circular economy thing, which is the recycle the life cycle of the particular parts of the project, and then sustainability consideration is also integrated into the project. And then stakeholder consultation is a continuous process that is being followed up in all the major phases of this life cycle of offshore wind farms. And the consultation process should begin early on. And then pre-construction site selection is the first process, which is done by either government or the developer. But whoever does it, it's need to be carefully done because it can conflict with fishing grounds. So, and also when the site selection is being done, sometimes seismic survey is conducted, which have negative impact due to its acute noise that it produces on fish. So in order to minimize the impact, what we can do is to avoid the fish spawning season while conducting these surveys, and also to avoid the nursery grounds where baby fish and their parents roam around. Migratory routes should also be avoided while choosing uh, sites and also while doing the surveys for site selection. And then followed by site selection, we have the construction phase, which is, we all know that which have the most impact on fish and fisheries, because fisheries activities are not being allowed during the construction phase. And this construction calendar should basically follow the spawning season, nursing season, and fish migratory season as well. Operation and management. This operation, which includes production and management, this is the longest period in a lifespan of an offshore wind farms. And during this process, negative impacts are very less as far as we know, but we don't really know what is the long-term impact because we don't know how long is long-term. So the oldest wind farm is about 30 years old, and the scientific document that we have say there's no really long-term impact of offshore wind farms on fisheries, so on fish species. So this is on our favor, but if the long term is considered as say 60 years, then we don't really know what's going to happen in another 30 years from now on. And during this operation phase, many offshore wind farms are now allowing fishing activities or passing or navigation of fishing vessels within the wind farms. Routine maintenance can have or repair work can have some kind of occasional stress on marine environment, which we can take care of by maintaining the calendar. And then consultation again is very important here. And one very crucial part here is the assistance of fishers who fish within or adjacent to offshore wind farms in monitoring and reporting, because in doing so, they can actually help the regulators by giving information on what's going on inside the offshore wind farms in terms of fisheries.
Arif, just to tell you, sorry for interrupting, just very quickly, you have about 2 minutes to wrap up. Okay. So okay. If you have a part that is missing, we can take it on the discussion.
Okay, I think in 2 minutes I will be doing the most important part, and then conclusion may be done later on. Yeah.
Okay.
So now the last part is last phase of the life of an offshore wind farm is decommissioning, and it has its impact as well, but we do not know it fully because not many offshore wind farms have been decommissioned so far. But what we know is decommissioning can have a couple of things. For a couple of decommissioning can take a couple of shifts. For example, it can mean removal or say recycling. So waste management comes into the play as well, and the decommissioning process, if it involves removal, then it will damage the reef effect, which is the positive impact of offshore wind farms on fisheries. So so we need to take care of this as well. And in order to minimize the impact of decommissioning or dismantling of offshore wind farms, environmental impact assessment is required by some countries, especially the North Sea bordering countries. And then notifying the stakeholder is really important so that they know when these infrastructures are gonna taken away, and then the calendar as well. So avoiding fish spawning season and fish breeding season, migratory season should be avoided in dismantling the infrastructure. And stakeholder consultation is something that I'm leaving for the next session. Here also we have a couple of important points for the regulators to keep in mind while making policies and regulations. Compensation is a way to mitigate these conflicts, but we would prefer compensation as a secondary means and not a primary thing, because compensations are effective in short term, but may not be as effective in the long term. And then there are pros and cons of these compensatory mechanisms, which we can discuss in the discussion session. So in conclusion, overall, offshore wind farms are beneficial because they're climate friendly, as they produce clean energy, but we need more of them. And offshore wind farms have negative effects on fish and conflict with fisheries, navigation, and other uses of the sea. So the regulatory framework can help minimize this negative effect, manage the conflicts, and maximize benefits. Regulators must consider the latest scientific findings and adopt appropriate approaches in regulating and governing these offshore wind farms. And marine spatial planning, licensing conditions are important tools, and consultations, stakeholder consultation are important tools that regulators must focus on. And I leave here. Thank you very much for your patience. Thank you for keeping the time ruthlessly, Ignacio.
No, thank you so much, Arif, for this